Hi, I am Igor Bakshee. I am with Wolfram Research, and my talk will be about the channel framework and the way how you can talk from any HTTP-enabled device to your Wolfram language session. So, and you saw my hands are here. I did not type that hello. That was a preliminary thing to execute. So, as soon as someone on their computer types in anything into that line on their computer, my computer will receive it, and everyone who subscribed to that channel, which is called Demos One-Liner, everyone will receive that hello. Hey also will do. All right. So this is a preliminary. How does it work? And in this talk, we'll briefly explain how it works. We talk a little bit about publish-subscribe model, which we use. We'll see when we need channel and when we don't need channels. And we get to know some fun applications not in great many details, but we'll browse through. So basically, what is channel framework? The channel framework allows any HTTP-enabled device talk to your Mathematica session. And that is very powerful. You probably understand that. Any HTTP-enabled device can now talk to your Mathematica session. And that, of course, includes Mathematica itself and many other applications. Virtually anything now can talk HTTP. And therefore, anything can now talk to your Mathematica session. So how it works? You execute a channel listen command. You give a name of the channel that you want to listen on. You enter some function that you want to execute when a message arrives. Or you can drop that part and execute a default listener. That is also fine. And you give permissions. In this case, I gave public. Anyone, as soon as I execute it, anyone can send commands to that speak channel, and my Wolfram language session will speak the command. And I also set up listener dynamic here. So as soon as message arrives, it will not only speak, but it will also update the listener. So now I cooked up a few commands. In this case, it's curl. So I am going to my terminal session. I am pasting this.
Arrived 123.
I'm not sure you heard this. Have you? OK, so people in the first row can actually hear that, but my Mathematica actually spoke the command. And we see that param 123 is also updated in my dynamic. I executed this curl on my machine, but actually this curl command can be executed anywhere on the internet, and your Mathematica session will receive this message. Another example, I built up a URL. I am going to my web browser, and I just paste that URL here.
Arrived 456.
Did you hear that? Yep. All right. So we are in business. Now,
456.
OK, it executed again. Never mind that. So, and of course, Wolfram language itself can do HTTP requests. And you can do URL fetch with that, the same URL. Or in Mathematica client, it can be even made more convenient. You just say channel send. Because I want this to be executed on anyone's machine, I did not say just speak. I said Wolfram ID, my Wolfram ID, :speak. And that will be fully qualified name of the channel. So if I was speaking between myself, I would not need this Wolfram ID. If you want other users to talk to you, you would say Wolfram ID, colon.
Look up. That's amazing. Param.
I didn't do that. I don't know what is happening. OK. So
Arrived 789.
now I did that. It's executed, it received. And on the Mathematica side, we can see that's amazing param. Did someone send that? All right, OK. So that guy spoiled the nice table layout here. If he didn't do that, that data set would be a nice table. But because it's a public channel, that actually brings up a good point. If there is a public channel, you should always think very carefully of what you want to execute on that channel. And basically, you do not ever execute any Wolfram language command on a public channel, because you can fry your hard disk.
Sorry, Igor.
Exactly. But in this case, it's harmless because it just speaks the message. But now I will remove channel listener before he sends some another command.
Yeah, where are you getting the URL? So I was trying to find inside of the documentation where the full URL for the channel.
Right. It's in several places. So the command to send via URL is in channel send documentation. That will give you that part. Let me highlight it. That operation equals to send, and then goes your URL encoded message. But the part of the URL itself, that one, is this listener URL. This will give you the exact URL to send your data to. OK. Now, what I did here, I removed that channel listener, and I did this because it's a public channel and I don't want anybody else like Bob doing things on my machine. But basically, it's a common hygiene. It can live there, the channel listener can live there, but you don't want hundreds of channel listeners hanging around and doing things that you don't want it. So just after you're done with the channel, do this remove channel listener. If you forget, nothing bad will happen. Channels will time out automatically. So what is happening here? Don't make photos of this page. I'm half joking, because the architecture is experimental, but there will be several aspects that are set in stone and will not change. And the basic is that there are clients, these clients, which is curl, browsers, devices. In this case, I have an icon of Arduino Uno, and of course, Mathematica clients. Those clients will send messages. There are other clients, like multiple Wolfram language session, which listens on those channels. And there is a server in the middle. And don't worry about that particular part, because there also will always will be a server which connects all these devices and services. So basically, what we have done is we abstracted away all minor details of how do you talk to this particular device, how this receiver receives the function. There is completely abstract way. The clients know only how to talk to the server, which is a regular HTTP request, for sending and for receiving data. So that part gives you actually a lot of flexibility. You can have one-to-one, many-to-many, one-to-many, many-to-one in any combination. So our chat that we saw at the very beginning, our toy chat, was that part, is many-to-many. As soon as you type that command, it will go to you and to anyone else listening on that channel. That was the many-to-many examples of many-to-many connections. So you don't always need channels. If you just want Mathematica to execute some Mathematica language expression and get the result back, you do not need the channel framework. You would use API function, form function, mail receiver function, and plenty of other tools to get your code executed in Mathematica. You don't need the channel framework. If you want to store data permanently, you would use Cloud Object, you will use Data Drop API. Again, you do not need a channel framework for that. Although channel framework can do all these things too. It can save data it receives in a data bin. It can go to save data in a Cloud Object. But if you only need that part, only saving or executing functions, you do not need a channel framework. Now, when do you need? If you want your particular Mathematica session to receive data and display them, for example, or execute a command in your particular Mathematica session, then you would be happy to use that channel framework because it will give you exactly that. And if, for example, I want to execute something on Bob's machine and he gives me permission to do that, then I can execute. No, he won't. OK, I will ask somebody else. Lexi is usually more cooperative. So you can execute the command on any other machine that gives you permission. That is also where the channel framework is very useful. Now, one application, obvious application for that is use your Wolfram session for the dashboards for remote data. So what I'm doing now, I have started to listen on a channel named points. And now I am going to OK, great. To my cloud account. And I do a command which will send data every second into Mathematica. It's just a run schedule task. So what is happening is that my cloud account sends data to my Wolfram language session. And you see here my Wolfram language session updates automatically. So basically, in this case, it's a run schedule task in a Wolfram language session, but it can be a device. It can be anything that you want. And it will work exactly the same way. So I'm stopping this nonsense. And I'm executing next command, setting up a listener in that session. But we will use that listener in a little while. OK, so now we create new listener. We start listening on a channel named local. And as you see, there is no messages here in that listener. So now we will send a command. And you saw that this dynamic updated, right? So what has happened? My local session, this session, sent data to my cloud account. My cloud account executed that my command automatically, and that was the listener I set up just a few minutes ago, that part in the cloud. There was a listener that I set up. So that listener executed a message that it received, and sent data back to the address that we used that in reply to field. So what has happened is that my local computer communicated with the cloud, got data executed there, and received the data back. And just so that you know that I'm not cheating, this operating system is Mac, and it has different machine ID. And Unix is our cloud account, which runs on Unix. OK, and of course, this thing can be used for many different exciting projects. For example, you probably all heard about SETI at home. So if you think of any globally interested projects that can be executed using Wolfram language, talk to us. We will help you to set it up. And if people will be willing to lend their Wolfram language power to your task, you will get that SETI at home set up in almost no time. So, and we can do it very securely. That is a separate issue.
You call that computational crowdsourcing?
You can call them that. Okay, great. I have no idea what's going on. Okay, something's missing. Okay, let's see if I can go without that. Okay, so another example is to talk to from devices to your Mathematica session. As we already discussed, if you're interested in details, go to Ian Johnson talk on Friday. He will be talking about Arduino, not necessarily Yun, but other Arduino shields that will talk to your Mathematica session. Another example is chat. We saw my little demo toy. It's not full-blown chat, but the code is provided. You can do any elaborate things that you want with that, and the code is in your Mathematica in version 11. Now, you can send, we call it WIM, Wolfram Instant Messages, between two machines. That example is detailed in the documentation for channel listen. Go look it up if you're interested, and you can see how you can send messages back and forth. And these messages can include any Mathematica expression or entire Mathematica notebooks. So you can send, you can do group chat and send exchange notebooks. And in fact, there is a much bigger chat framework is being developed, and today people who will be who will participate in that competition tonight, hopefully will be using that more sophisticated chat tool than I'm describing here. Now, you can integrate with IFT or other cloud services, and if you're interested in that, there is a very interesting demo running downstairs in the connectivity booth. Go and see it. You will see how it works. You can connect, you can use the same thing in mail receiver function on any API function. So you probably know how to use API function already. So if you want to know who executed a command in your public API function, and you will see locally, for example, list of users as they execute your commands, you can just add channel send to your API function, and your Mathematica session will live update you on anyone using your API function in the cloud. It is very easy. That example is also in the documentation. I'm not going to, Jesus. Okay, I'm running out of time. Let's see if the second point. Okay, now. Activate. I don't have too much time to experiment. Okay. Okay, sorry about that. Let me try to launch this again. Mathematica is very strict, apparently, about licensing. I cannot hear you. Okay, cannot. All right. Okay, so if you give me a couple of minutes, let me. Okay, it does not quite work. I will have to somehow remember what the hell I was supposed to talk about. Okay, so we saw how to run that. Okay, other examples. You can communicate with serverless applications, like, for example, Amazon Lambda. There is an example, actually, it's also in the documentation, where you put things into your S3 example, and as soon as new images, for example, drop into your bucket, your Mathematica will receive and automatically update your images. That is another example. Right.
Do you have VPN on here?
No.
You'll have to have it probably. You have a key.
Do you have my notebook?
I don't. I need to go to my top.
All right, okay. We don't have time for that. Okay, so I'm almost done. Just to sum up, any device that can talk HTTP can talk to your Mathematica session right now. The functions that you define in the channel listener or on the channel, in the definition of the channel, can be anything that you want. There is a powerful permission mechanism. There are different areas you can give different people or different groups of people execute permission, write permission, read permission. Everything is taken care of. It is safe to evaluate, not to evaluate, it is safe to receive a code in your session, because your channel will wrap it in hold all complete, and there are the disable formatting feature that will make the code completely inert. So it is safe to receive data on a public channel. That is taken care of. But if you receive data on a public channel and apply release hold on it, you're fried. So don't ever evaluate anything on a public channel. Look at it first. So that part is, has already been worked out. And if you have more questions after the talk, I will be in the connectivity booth downstairs Friday 10 to 12. You're very welcome to come and talk, and I will demo everything in much greater detail. Please, questions. Thank you.